this little short linear lesson today because it puts stuff into real life context. So that's always interesting to me when we get to see how it's going to apply real world type stuff. May need a pencil. So we can't just doesn't have to click on it, but it sounds like it's got it. Alright, so I've got to draw a little bit on this, so give me a minute to get this first little graph drawn that we're going to use. That one. Insert. That's the other way. It's up the line there. Well, let's try to get that thing straight there, you retard. Delete. I call myself that. It's not true. Oh, I thought you were laying down first. No. I haven't even started yet, Bonnie. Don't give up. It's not that bad. Okay, I need to draw my foot. That'll be good enough. Alright, so what we got here, this is stuff about an asteroid, and I'll read it to you in a second. Over on the y-axis, that's going to be the distance in miles. And on the x-axis, it's going to be the time in seconds. You don't have to be precise on drawing that there. It's just something that's got a good positive slope going through there. I'm going to just pick a point and we'll say that that point is at 5 seconds and 24 miles. Over 5 up to 24. Alright, so it says that what the problem that accompanies this says, the graph shows the distance asteroid 2012 DA14 travels in x seconds. We were told to write an equation of the line and intercept the slope. The asteroid came within 17,200 miles of Earth in February 2013. How long does it take it to travel that distance? So first thing we got to do is take this line that they've given us and write an equation out of it so that we can use that equation to answer the follow-up question. Okay, so one of the easiest ways we know to write lines that we learned in Algebra 1 is we know a line is slope-intercept form, mx plus b, right? Everybody remember that? Pretty easy step. What is the b on this line? Where does it cross the y-axis? Trevor knows. Anybody else know? Good, good. It hits it right there at the origin. So it's got a b of 0. So I can put plus 0, but I don't have to, right? Now I got to find out the slope. Do you know the slope? You do. Remember slope, it's the m thing here, right? And there's a formula you can use to find slope, but also the short thing that I'm going to use on this one is slope is our rise over our run, right? So to get from the origin up to this point, if I'm looking at my rise over my run, how much would I have to go up? Nope. 24. Good, Carrie. Remember the second one is your y, right? Everybody remember that? So from the bottom to that point, I would have to go up 24. So I got 24 over, how much did it run to get from here to here? 5. So the slope is 24 over 5. Now normally, I leave my slope in a fraction form because it means rise over run. But if we're putting this into context with this problem, trying to find out distance and time, probably would be a good time to go ahead and convert that to a decimal. So what's 24/5 converted to a decimal? Well, grab that calculator and do 24 divided by 5.
Is that slope x1 and x2 and y2, or y1, y2 over each other?
Yes.
Yeah, that.
Yes, that's the formula for slope, yes. Say that slope again for me. 4.8. So my equation for this line, I'm going to write it right there on it, is y equals 4.8x. Now before we answer the question, I've got to read it to you again, you already forgot it. I want to think about what that means in relationship to this graph, because we get caught up and we're just like, oh, slope, that's how steep it is, but I don't really think about what that means in relationship to the problem. If I'm the asteroid that they're tracking, wouldn't that be fun to be an asteroid until you hit something and blow up? Across here is my time. Here is how far I go. So this is how long I'm flying. This is how far I'm going. What does this mean? which, I've got y as an x, okay? So which, is time the x or is distance the x? Time, it's on the x-axis, good, Connor. So I'm taking my time and multiplying it by 4.8, and that would tell me how far I went, right? So for every second, because it's in seconds, every second I would go 4.8 miles. Okay, so sometimes we don't do that. We don't make the connection for what the equation means to how it's really real world. And slope is a rate of change. So for every second I travel, I'm going 4.8 miles. Pretty neat to think about it that way. All right, now, there was a follow-up question. You can go and read it because I forgot it too. Don't worry, it wasn't just you. Just a minute.
Who is it?
Hey. I'll have my glasses on so somebody can see later. Okay.
This is your copy. Sign this one. Make sure that
Put her box
that's
around.
on it. That's on it.
Okay, gotcha. Thank you. That's like harsh. All right, so the follow-up, y'all ready? Here we go. The follow-up says about how long does it take the asteroid to travel the 17,200 miles to Earth?
Could you just times 4.8 by that number?
That's what we got to figure out. Does the miles go in the Y or the X spot? Goes in the Y because the miles is on the Y-axis. So instead of plugging it in for the X, we're going to plug it in for the Y. So I said 17,200. Let me get a new color so we can see it. 17,200, because that's the miles, is equal to 4.8 times I don't know how many seconds. So now how do we figure out how many seconds if it's being multiplied by 4.8? I'm trying to solve for X, that's the seconds. It's being multiplied by 4.8. How do I solve that? Good, Jody. We undo multiplication by dividing. So we're just going to divide both sides by 4.8. 3,583 point. Is it repeating on the 30?
Yeah.
Alright, now, we're going to take that even farther because that doesn't mean a lot to me. Does that mean something to you? That's in seconds. How many seconds? 3,583 and a third seconds. Can I make that conversion to anything?
Minutes?
Minutes? Good, that'd be good. How could I do that? Oh, divided by 60. So how many minutes is, let me label something. How many minutes is this?
59.7.
59.7. And that means more to me because that's almost an hour, right? Now the correct answer was the first one you got, but I just like making these real world situations. So it took, say that again, Carolyn? You wish what? Yeah, I agree. Took us almost an hour, the asteroid, to travel 17,200 miles. What does that mean? Does that make sense to you? Do you know how far 17,200 miles is?
No.
I don't. I've never traveled a trip that went 17,200 miles. I don't know if an hour is good or not. I have been to Africa. I don't know how far that is. But I went in a plane, and it took more than an hour. I was all day on a plane. Actually, 2 days. I spent those were layovers. Spent the night in an airport one time. So I don't know how fast that is. Y'all got any idea?
That's pretty quick.
It is? Man, I'm thinking asteroid's booking it.
Because it's about 1,800 miles to get to Jersey, and we drove.
So times 10 on that to get 17,000, yeah.
Yeah, and it took about like
That's
25
pretty
hours
quick.
to get
Yeah.
there.
So those asteroids, whew. But you think about, like, I don't know, I guess the last movie that I saw about asteroid was Armageddon, and that was a long time ago. Anybody see Armageddon? It was
Yeah, I
like-
think they're moving so fast they're on fire.
Yeah. And
Pretty quick.
so, yeah. Then it burns up.
Mhm.
All right.
Not all asteroids were on fire.
Well, it is a ball of fire, yeah. But, because they're going there. I'm not, we'd have to get who's the science people? Osbrooks, I think he knows about asteroids. I think that'd be more in his situation than it would be Osbrooks and Davis. Alright, so pretty simple problem there, but we got lots of good information out of it. I like this type of problem more than anything we've done all week. because this is more figuring out, applying to real life, and I like this. Does that mean we don't have to worry about all the stuff that we've done all week? No. And it's those things that if nothing else, you might see on the ACT, you might see on the ACT Aspire, we got to get it done. Go.
So, when we got 4.8x, is that like really all we have to do?
On the two questions we were asked was for the equation, so that was the one of them, and then how long did it take it to go the 17,000 miles? So we had those two questions, yeah. Oops. Okay, everybody feel good on that? Good there, Monty Pete? Did you say yes, ma'am? All right, we'll give us another one similar to that, and then we'll move on. Alright, what I got on this one is the y-axis is the balance, and it is in BALANCE. It is in thousands, or right sideways, of dollars. Then my x-axis is my number of payments. Okay, and I've got 2 points on my graph there that I'm going to give you. This point is at 0, 18. And then I got another one not far from it at 10, 15. So this one's going to be a little bit different. Alright, so first off, before we even read the question, let's think about what we've got there just in relationship to the way I've labeled the graph. Number of payments is my x-axis. Thousands of dollars is my y-axis. So when I've made 0 payments, are you following this? 0 payments, because there's a 0 on the x, I have a balance of $18,000. Can you see that? Yes, ma'am?
Can I see Molly Pittman for a moment?
Sure.
Thank you.
So after I made 10 payments, you know, I paid money outright. After I made 10 payments, my balance went down to $15,000. Okay, that's why we see a negative slope here, because the more we make, the more payments we make, the less money we're going to have in the bank, because we're writing a check out of our bank account. Everybody make sense on that? Okay, pretty good. Okay, so let me read what we're asked to do here. This is on a car loan, by the way, so that's what we're talking about, paying our car off. It says the graph shows the remaining balance Y on a car loan after making X number of payments. Write an equation of the line and interpret the slope and y-intercept. What's the remaining balance after 36 payments? So we got to write an equation of a line. Okay, which means we need a slope. Oh, sorry. So how can we find a slope here? What did you just say, Stephen? Oh, I thought you were telling me how to find a slope.
I set this slope. You do. Figured out the slope, but it's y2, or take the second y minus the first y, put it over the second x minus the first x.
Good. That's, and Trevor reminded us that too. Good, Stephen. That's the formula for slope, so we could get it that way. We could also still count rise over run if we wanted to, since we got 2 points. So either one of those ways would work. Let's go ahead and do what Stephen just described. Which one of these do you want to use as your y? My y's are 18 and 15. Okay. Which one do you want to use as your y2?
18.
Okay, if I use that one as my y2, that means 0 has to be my x2. They got to go together. You can't have a 1 and a 2 up there, right? So this one will be my x1 and my y1. Now, what if somebody else said they wanted their 15 to be the y2? Could they do that and get the right answer?
Yeah.
Yeah, as long as they stayed consistent. All right, so we're here at 18 minus 15 over 0 minus 10. So that would be 3 over negative 10. Does it make sense to me that that's a negative? Yeah, because my line's going downhill. It has a negative slope. Now you could leave that as negative 3/10, or since we wrote the last one in a decimal, that would be negative 0.3. 3. Everybody okay? Do I know the y-intercept of this graph, or do I got to figure that out? Do I know where it's crossing the y-axis? Yeah, this one tells me. Sometimes it won't, but this one does. Where's this one cross the y-axis? 18. 18 is on the y-axis. So that's my B. So the equation is y equals negative 0.3x plus 18. Alright, so what does that mean in talking about paying off a car loan? I got you.
Molly P.
Molly P. Yeah. So, what do we got? Number of payments is my X. So I'm taking my number of payments and I'm multiplying it by negative 0.3. Then I'm adding 18 to it. So how could we relate that in a real life scenario? How could you describe what's going on just with that equation? Remember the balance over there on the y-axis says it's in thousands, right? So if we took that 0.3 and multiplied it by 1,000, wouldn't it be 300? That might be important. So the balance, since it's negative, would you think that's increasing or decreasing? Up or down, since it's negative? Good, Carolyn. Decrease is going down. So the balance is going down $300 every time we make a payment, right? But then, what about that 18 on the end? Okay. How much did the car cost? It cost $18,000, right? That was our initial amount in thousands. So the car cost $18,000. So we're taking $300 off. That's why you'll get a negative here. You're taking $300 off of that $18,000 every time you make a payment. Does that make sense? Okay, let's see. I think you want to know after 36 payments, how much would we, let me make sure. It says, what's the remaining balance after 36 payments? So where's the 36 going to go in on this one? Which one's my payments? X or Y? X, good. So this one's going to go in for the X. So we're going to say Y equals negative 0.3 times 36 plus 18. What do you got? Everybody check it out. See if y'all got the same thing Carrie Lynn did. That's what Connor got. That's what Don got. Did it come out at that, or did you?
No, I can't.
Good. You got it, Stephen? Okay, everybody good?
I just tried to go back 300 to that amount.
Oh, okay. So Carolyn went the common sense way and didn't even use the equation and still got the same answer. Connor, did you use the equation, or did you just subtract? What'd you do?
I just did 300 times
Okay.
18.
That's what Carolyn did. Good. Did anybody actually plug it in the equation?
Too much work.
Do what?
That's too much work.
Plug it in the equation for me real quick. Do this right here. Do negative 0.3 times 36 and then plus 18. Yeah, that's right, Stephen. Oh, yeah. That's why I wanted, go back to that. Yeah, that's 7.2. That's why I wanted to talk about that, because when you do that, when you plug it in the equation, you got 7.2. So then you had to look over here and remember that that's in thousands. So you had to move the decimal point 3 times. Okay? That's why I wanted you to look at that. Okay? Okay. Feel all right there? All right. This next problem, we're going to have 2 functions to compare. So the first one, I've got a table here. This is going to be Lakeside. My table, I've got number of students. That's going to be on my X. Then I got total cost. That's going to be in my Y. All right, we go 100, 125, 150, 175, and 200. Okay, when I had 100 students, it cost me $1,500. When I had 125 students, it cost me $1,800. When I had 150 students, it cost me $2,100. When I had 175 students, it cost me $2,400. And then when I had 200 students, it cost me $2,700. And then we got another hotel called the Sunview Resort. And they just gave me their equation. Alright, so get that info and then I'll read to you and tell you what we got and what the challenge is. Yes, 10x plus 600. Sorry about that. Alright, so here's the situation. It says 2 prom venues charge a rental fee plus a fee per student. The table, that's over there on the lakeside one, the table shows the total cost for different numbers of students. The total cost Y in dollars for X students at Sunview is represented by that equation. This says which venue charges less per student. That's number 1. So which one will be cheaper per student? Number 2, how many students must attend for the total costs to be the same? So we got to figure out which one's cheaper per student, and then when would their costs be the same? How many kids would mean their costs would be the same? Alright, so if we're looking for which one's cheaper per student, what's going to be important to us? What mathematical thing that we've been talking about today would tell us the cost per student? We've been finding it since we started. The slope, right? The slope. So what's going to be important to us? So we know this one has a slope of 10. So if the X is the number of students, they're charging $10 a student, right? So we got to figure out how much Lakeside's charging per student. So we got to figure the slope out of this one. Okay, so we're going to use that equation that Stephen, he's ahead of me already, but we're going to use that equation that Stephen and Trevor have been talking about. Subtract by Y, so I'm just going to use these first 2 points. What's 1,800 minus 1,500? 300 over 125 minus 100? And what's 300 divided by 25? Good. Everybody see what we did on that one? So this Lakeside Inn is charging $12 a student. Sunview Resort is charging $10 a student. So for our first few answer, which one's cheaper per student? Sunview. Okay? Now obviously they're adding, a $600 charge on the end, and these are too. There's some charge that's added there as well. We just don't know that yet. So the costs are going to be different. It wants us to find out how many kids would have to come before they're equal. Where does it equal out at? That's right. I'm going to go ahead and write that over here because Dalton is correctamundo. Dalton, how'd you get that? Okay, good. Dalton's taken these numbers that we have here because and this is good common sense and I like it because we already know their cost. So he said, all right, it costs 100 kids, costs $1,500 there. I can plug 100 in here, see how much it costs, and it wasn't $1,500. So he went to the next one, 125, and saw it's $1,800. Plugged 125 in here, and it wasn't $1,800. So he went to the next one, 150, plugged it in here, and he got $2,100. So he knew that at 150, it was costing the same. Now here's my only problem with that. What if it was a number in between here?
You use your common sense. If it ain't going down, just make up a number and go down.
If you're a good number picker, that'll work. But what if you like keep picking numbers and you never get it? What if it's like 119 and you picked every number but 119? Okay?
Well, maybe you just,
So
you
then you're screwed, is what the guy said. No, I don't disagree with you, Trevor. And it does, but sometimes we need a way without having to spend 45 minutes picking numbers.
Yeah.
Okay? And I like that. When I did it the first time, I did what Dalton did on that. But then I got to think of how this would work every time if it's not up there. So we already know the slope of this. Say it again, Willis. That'd be a good, yeah, that'd be a good idea to start. But we already know the slope. This one's got an equation. If I could get an equation of this one, I could set them equal to each other and solve and see where they come out equal to each other. So I've got the slope. I need a b. I don't know it because it starts at 100. B would be where my x is 0. It's a 0 comma something, right, on the B? Y'all remember that? So I got to have a way to find out the B. And this is what a lot of people forget from Algebra 1. Y'all done great remembering so far. There's this is slope-intercept form. There's one called point-slope form. It starts off as y minus y1 equals m times x minus x1. I can use that to get to my b. Okay? The m we already know. We're going to put a 12 in its spot. The y is going to stay, where my mouse is here, is going to stay a y. The x is going to stay an x. I just get to pick my favorite point over here and plug it in the y1 and the x1. So I always use the smallest one, so I'm going to plug 100 in my x1 and 1500 in my y1. Okay, so I'm going to say y minus 1500 is equal to 12 times x minus 100. Now we just got some basic algebra to simplify this thing down. Okay, good. Trevor's distributing y minus 1500 equals 12x minus 12,000. Or that's 1200, dummy, right? Okay, now remember we're trying to get it in slope-intercept form. So the only thing that we've got to move
is plus.
Good, Trevor. We're going to add 1500 to both sides. No, we'll be able to stop there. 12x plus 300. So this would be the equation that makes that table. We just wrote the equation for that table. We still haven't found the answer that Dalton had 20 minutes ago yet. So I said that the answer that Dalton told me, how many people does it take to make the prices be the same? It's 150. So I'm looking for the prices to be the same. And y is my prices, y is my cost. I'm just going to set 12x plus 300 equal to 10x plus 600. That equal means the same, right? So we're going to say, I'll scoot it up so we can see it after I write it. 10x plus 600 equals 12x plus 300.
Do that backwards, yeah.
Yes, it'll work either way. Good student. Alright, so we're solving this thing here for x. That'll tell me the number of students. We got 4 parts in that equation. So you can pick any of those 4 parts you want to start with to get rid of first. Anybody got an idea how to start that?
Subtract 300.
Okay, Chloe said subtract 300. That'll work. Other answers would have worked also. If I subtract 300 from itself, I got to subtract it from its like term on the other side. So it gets me 10x plus 300 equals 12x. Now, after Chloe did that, she doesn't have a choice on what to do next. She needs to get those x's together. Say that again. Minus 10x. Good, Stephen. Let's subtract 10x from both sides. So that got me 300 is equal to 2x. So what's the last step? Good. Good. And there's that answer that Dalton told us half an hour ago. Take 150 kids for them to even out. So let me go back. The Lakeside Inn charged $12 a student, and the Sunview charged $10 a student. So if they even out at 150 students, if I was going to have less than 150 students, which one would I probably want to use? The Sunview, because they're charging less per student, right? And once I hit more, I don't know. Would it be See, if I had 1 here, that would be 610. If I had 1 here, that would be 312. So fewer students we would want to use Lakeside, right? Once we get over 150, we want to go to Sunview. So they got different charges, whatever that deposit is, they're sticking on the end there. All right, the last one that we're probably going to look at today has to do with the line of best fit. Y'all remember lines of best fit? When you've got a scatter plot with just a lot of points and one line doesn't connect them all, but you can get a line that goes close through them all. Okay, that's what we're going to look at real quick on this one. So I've got a table that has to do with bone lengths. We've got the length of our femur length, and that's going to be my x compared to my height.
You know what's like the hardest organ break in your body?
It's one of the biggest, if not the biggest, yeah. Alright, so I've got a bunch of these. Let me get them all written down here. I've got 40, 45, 32, 50, 37, 41, 30, 34, 47, and 45. So there's all my femur lengths. Now, on this survey here, a person that had a femur length of 40 was 170 inches tall. A femur length of 45 inches was 183. 32 inches was 151. 50 was 195. 37 was 162. 41 was 174. 30 was 141. 34 was 151. 47 was 185. And 45 was 182. Oh, my bad. There's, yeah, that is tall. 30 centimeters. I just now read that. Yeah, you're right. That would be like way tall. Because 5 foot 60 inches. So that would be crazy. All right, so here's what we got. And I was saying inches a second ago in centimeters. Don't think these people are giants. It says the table shows the femur length in centimeters and heights in centimeters of several people. Do the data show a linear relationship? If so, write an equation of line of fit and use it to estimate the height of a person who is 35 centimeters long. So, Dalton.
How do they do 40 pounds different?
Different people. I mean, everybody's doesn't grow exactly the same. They ought to be close, are they? Yeah, they're just a centimeter off. So, that's a good question. That would be like if, you know, somebody's exactly the same height as you, maybe their bone is not finished growing. I don't know. I'm not sure.
You just put
I copy it. All right, so the first question is, does it show a, do the data show a linear relationship? So to figure this out, what we're going to do is graph it and see if it looks like it would make a line. Okay, so I'm going to graph them here. Now, on my X, the smallest femur length that I have there looks like 30. So I'm going to do a break in that graph. So if that's 0, I'm going to start here at 30. Okay, so I don't have to count every single one of them over there. Then I'm going to count. There's 40, 45, 50. How much higher do I need? Is that it? Would that be high enough? Yeah. Okay, and then on my heights, I'm going to count. Let's see, I got to go all the way to 195. Looks like my biggest height. So I want to count maybe by 40s. Let's try that. Let's see here. This is 20. There, I'm going to put it on the inside. 40, 60, 80, 120. I didn't make it high enough. 140, So that next one will be 160, so I'm gonna, I need to scoot all mine down. Dadnabbit. Make this one be, I'm screwed up. Still gonna count by 40s, I just didn't space them out enough for my paper. 80, 120, I want to have a weight room. 160 plus 40 is 200, so that'll be clean. Okay, so we're just going to go down the chart, start plotting all the points there. I got to go for that first one over 40 and up to 70. And since we're estimating here, this is not going to be exact. My second one over 45 up to 183. Okay, y'all plot y'all's. 32, 151, 50, 195, 37. Wish y'all like me to quit talking so you can do yours, huh? Should be 170. Is there another 40 in there? No. So that one should be up here. Well, I got that short one. Y'all get it? Something looks similar to my graph? Okay, the first question that I asked you was, does the data show a linear relationship? Yes, Dalton is correct, it does. I could draw a line of best fit that would represent those points, because even though they don't all fall directly on a line, they do look like they've got a good positive slope, and so I could draw a line through that to represent that. Okay, we know, draw this over here on the side, we know I could have something that looked like that. That would have a positive relationship. I could have something that looked like that, even though they're not all on a line, they do have a negative relationship, right? And then the other option is just points scattered everywhere. Okay, but this one does have a positive relationship, so you could draw a line of best fit that goes through most of those, a good representation of those points. Okay, so yes, this has a linear relationship. What kind? Positive, because it's going uphill. Okay, from there, it asks us to write an equation for our line of fit. Will every equation of line of best fit be the same? No, that's very good. Because you have to use those points that you plotted to find the slope. And I might use 2 points, but Trevor might use 2 different ones. So it's possible that our equations are different, but they should still be close. Now when you choose points, I try to choose 2 that are pretty much closest to being on the line. Like right now, I would not use, with the line I drew, I would not use these 2 points, because they're way off my line. So I would try to pick a couple that are right on it. Okay, I like that one and that one. Those are kind of right on my line. So that would be, that one's a little bit more than 40. Maybe that's my 41 one, you think? Okay, so I'm going to say 41 and 174. And then this one is a little bit past 45. So maybe that's my 47 one. 47 was 185. And I would use those 2 points to find my slope. Okay, listen real quick, because this is fixing to be the shortest homework assignment you've ever had. What I want you to do for Monday is bring me back the equation for that line using those 2 points. So write down those 2 points so you'll at least know the right 2 points to use. 41,174 and 47,185. I want the equation for a line that'll go through those 2 points Monday morning. Okay? That's not too hard. You can probably do that before you leave school today so you won't have any homework. Make sure you got the right 2 points written down, because if you choose 2 different points, your equation will be different. That doesn't mean it's wrong, but that's not the one I'm going to look for Monday. Okay? Lucille.
Are we not gonna have any class?
No, I had one, but we don't have time for it. I'm sorry.
All I know is I'm not ready for no English.
Sure you are, Trevor.
Yeah.
It was my worst subject.